third part of the Nomenclature of Coordination Chemistry lecture series. In this part, I am going to deal with 3 examples. So far, we have learned 3 rules of the naming of coordination compounds. So, based on the knowledge, we are going to understand how the coordination compounds are named. In our first rule, we have seen that the neutral coordination compounds should not contain any space, but in ionic compounds there should be a space between the cation and the counter ion part. Rule 2 tells us while naming the coordination compounds, the name of the ligands come first, then the name of the ligand comes next. Finally, the oxidation state of the metal is enclosed in the parenthesis in a Roman numerical. Rule 3 indicates the prefixes di, tri, tetra, etc. while naming the coordination compounds. Now let us see the examples one by one. Let us first take the first example, Na2 NaCl4. The first thing we have to do is to find whether this is a neutral compound or ionic compound. It is clearly seen that this is an ionic compound because you have sodium before the coordination pair, therefore that is an ionic compound. So first you have to start writing with the name of the cation, and sodium is written first. So in the case of an ionic compound, there should be a space between the cation and the rest of the counter ions. Therefore sodium is written first, and I have left a space here. Then now come to the naming of this part of this ligand, NaCl4. So while naming the complex part, the ligand is named first. So first I have to write the name of the ligand, chloro, and you see there are 4 chlorine atoms are attached here. Therefore I have to use the prefix tetrachloro. So tetrachloro. Then there are no more ligands here. Therefore the name of the metal comes next as nickel, nickelate, and the oxidation state is represented here as 2 in the numerical. And you know how to find the oxidation state. However, I will explain it one more time. You have to find the oxidation state of nickel, and I put X for nickel. There are 4 chlorine atoms present here, and each chlorine atom carries a -1 charge. Therefore X plus 4 into -1, and which is equal to -2. You may wonder how this -2 comes here, and you see this compound is an ionic compound. If you split this compound, it split like this, 2 Na plus, and the counter ion, that means the ion which is present inside the coordination sphere has a charge of -2 as indicated here. Therefore here you have -2 charge. Therefore I have put -2 in this position. So X plus 4 into -1 is equal to -2. Therefore we have to, next step we have to find the value of X, and the value of X is found to be +2. So after finding the value of X, you have to write at the end of the name. Therefore this compound is sodium space tetrachloronickelate 2. Now we look into the second example, that is PTNH3 twice Cl4. So first question is whether this is a neutral complex or ionic complex. Here you see there are no atoms present before and after the coordination pair. Therefore this is a neutral compound, and I have to take a different color. So this is a neutral compound, and therefore the overall charge here is 0. Then in our previous class case we have only one type of ligand, but we have 2 types of ligand. One is ammonia, another one is chlorine. Since this is a neutral ligand, we do not need any space while naming the coordination compound. Therefore, first we have to identify which ligand comes first. The order of the ligand is more important. We have to look into the ligand types ammonia and chlorine. And ammonia starts with the alphabet A, chlorine starts with the alphabet C. Therefore, amine should come first. So amine comes first, next comes chloro. There are 2 ammonia molecules, therefore this is diamine, 4 chlorine molecules, therefore tetrachloro platinum 4. Again you see here the 4 written in the numerical or Roman numerical indicates the oxidation state, which is found here. X is, we have to find X, that is the oxidation state of platinum, plus 2 into 0, 2 ammonia molecules, and each ammonia molecules carry 0 charge, that is a neutral, therefore I have put 0. 4 into minus 1, each chlorine carries a minus 1 charge, and the overall charge of the complex is 0. Since this is a neutral complex, its charge is taken as 0. Therefore the value of X is found to be plus 4, and it is represented here. Now we move on to the our final example, PTNH3,4Cl2, and this is also a neutral complex because there are no ions present before and after the coordination pair. Now let me ask you a question. Which of the answer is right? Whether this is tetramine chloroplatinum 2 or dichlorotetramine platinum 2. Before find out, we can calculate the oxidation state. X plus 4 into 0 plus 2 into minus 1. Oxidation state of the charge of ammonia is 0, it is a neutral complex, and the charge of chlorine is minus 1, and overall charge is plus 2, and in both the names the charge is indicated as 2. Therefore there is no wrong in calculating the charge. Only we have to find whether the name is tetramine chloro dichloro or dichloro tetramine. Some of you may have think here this di starts with the alphabet D, and here the tetra starts with the alphabet T. So sometimes we may be tempted to do dichlorotetramine platinum 2 as the right answer, but our rule clearly states that this prefixes di and tetra should not affect the alphabetical order. We have to look only into the ligands, not the number of ligands. Look into the ligands. Here this is chloro having the alphabet C, ammonia having the alphabet A. Therefore A and C. So A should come first. Therefore the correct name is tetraamine dichloroplatinum 2. So this name is the right one, and this name is the wrong one. So in this part we have seen how to name a coordination compounds based on the 3 rules so far we have learnt. So if a cation is present, it should be named first, followed by a space, then the counter ion is written next, and we have to find the oxidation state, and it is indicated in the Roman numerical. Neutral compounds or neutral coordination compounds are written without any space, and if different ligands are present, then you should follow the alphabetical order. Again, the prefixes should not affect or does not have any role while writing the name of the complex. Hope you have understood all the examples I have discussed here. I will teach you the other set of rules in the next part. Thank you.